Alright, so in this video we'll be looking into the idea behind like and unlike terms. So two algebraic terms are considered like terms if they have the same set of variables. Let me write that down. So like terms. Now what does that mean? For example, let's take 2x and 3x. And as we discussed in the previous video, an algebraic term consists of a coefficient and a variable. So if you have a look at this algebraic term, the variable is x. And this algebraic term also has the variable x. So therefore, these two are considered to be like terms. We look at another example. Let's say 3a and 4a. Again, the variable for the first algebraic term is a, and the variable the second algebraic term is also a. So they're both having the same variables, so we call them like terms. Let's have a look at this. 4x and 5y. Now if you have a look at this, the first algebraic term has the variable x, and the second algebraic term has the variable y. So they have two different variables. Therefore, they're not like terms, they are unlike terms. Unlike terms. Let's explore a few more examples. Let's say 3ab and 4ab. Now, if you have a look at this, the variables on the first term are a and b, and the variables of the second term is also a and b. So both of the algebraic terms share the same set of variables. Therefore, these are also like. Okay, let's have a look at this. 7xy and 4yx. Now you may notice that the order of variables have changed, x, y and yx. However, the set of variables are still the same. This also has x and y. This also has x and y, but in a different order. And the order doesn't matter as long as the set of variables, in this case xy, is same for both the first term and the second algebraic term. Therefore, these are also like terms. Like terms. The reason for this is that they are being multiplied, as we've already discussed in the previous video. And we know that multiplication is commutative, which means the order doesn't matter. Whether you say 5 times 2 or 2 times 5, you're talking about the same value, which is 10. So whether you say x times y or y times x, it doesn't really matter. It's still the same thing. I can even rewrite this 4yx as 4xy. And therefore, these two terms are still like terms. Okay, so let's have a look at this one. 3a squared b and 5ba squared. Now again, observe the variables. This has a squared and b. This also has a squared and b in just a different order, just like the previous example. So the set of variables are still same, a squared and b. Therefore, these are also like terms. Let's look at another example. 8x squared y and 3xy squared. Now if you have a close look at this, you see that the variables on the first algebraic term are x squared and y. So the variables are x squared and y. The variables of the second algebraic term are x and y squared. And these are not the same thing, because x is not the same as x squared and y is not the same as y squared. This just means this is xy, right? X squared means there is 2x multiplying with each other. So this is just xxy. And this is xyy. This has 2x and 1y. This has 1x and 2y. So when the powers are different, it matters. They're not going to be the same variable anymore. The variable x and the variable x squared are completely different, just like how x and y are different. Just because they both share the same base x doesn't mean that they are the same variables. In fact, as power changes, the variable changes. So x to the power 1 is different from x to the power 2. Which is completely different from x to the power 3, which is completely different from x to the power 4, and so on. So when the power of a variable changes, we treat that variable as if it's a completely different variable. So we see here that these two have a different sets of variables. This has xy, this has xyy, and therefore this is unlike terms. Unlike terms. Let's have a look at this example. 4axy, comma 3xya, comma 5xa. In this example, we have three algebraic terms, and if we look at the set of variables of each of the algebraic terms, it's the same thing. It's x, a, and y, but it's just put in different order each time. So this is axy, this is still axy, this is still axy. So it's still the same set of variables as I mentioned, but just in different order. So this is also like terms. Let's have a look at one final example. 3a squared bc, comma 5ba squared c, comma 7bc squared a. Let's analyze the set of variables. The variables that are present in the first algebraic term is a squared, b, and c. So the variables are a squared, b, and c. Notice that the squared variable here is a. In the second set of variables, the squared variable is still a. So it's still a squared, b, and c. So it's still the same set of variables. However, in the third algebraic term, the squared variable is not a, it's c, which means the variables in this set are a, b, and c squared, which is different from the previous two sets. So we may say that these two are like terms. These two are like terms, but if you consider all of these three together, then they are unlike terms. So if you only take the first term and the second term, then yes, they are like terms. But if you were to consider all three terms, then we call them unlike terms. Hope you now understand how to identify like and unlike terms. And if you found this video useful, hit the like button and subscribe for more similar videos. And also please feel free to comment below if you have any questions or if you have any topics that you want to suggest for my next video. See you again.